Hello everyone, welcome back to the channel. In today's video, we are going to simplify one of the most important concepts in computer networking, the OSI model. If you are studying networking, preparing for IT certifications, or working as an IT support or network engineer, understanding this model is essential. The OSI model divides network communication into 7 different layers, each with a specific role in how data travels from one device to another. By the end of this video, you will clearly understand what the OSI model is, what each of the 7 layers does, and how data moves through these layers during communication. Let's get started. The OSI model stands for Open Systems Interconnection Model. It was created to standardize how different computer systems communicate over a network. Instead of handling communication as one complex process, the OSI model breaks it into 7 logical layers. Each layer performs a specific task and communicates with the layers above and below it. This layered approach makes troubleshooting easier and helps engineers design better networks. The 7 layers from bottom to top are physical, data link, network, transport, session, presentation, application. A simple way to remember them is, please do not throw sausage pizza away. Now let's explore each layer. The physical layer is the lowest layer of the OSI model. This layer deals with physical hardware and signals that transmit data. It includes things like network cables, connectors such as RJ45, electrical signals, wireless signals, network interface cards. Examples of technologies used here include Ethernet cables, fiber optic cables, Wi-Fi radio signals. In simple terms, the physical layer is responsible for sending raw bits, ones and zeros, across a physical medium. The data link layer is responsible for device-to-device communication within the same network. Its main job is to ensure that data can move reliably between devices connected on the same network. Key responsibilities include MAC addressing, error detection, frame formatting, switching. Technologies and protocols here include Ethernet, VLANs, MAC addresses, switching protocols. Network switches mainly operate at this layer. Think of this layer as the traffic controller inside a local network. The network layer is responsible for routing data between different networks. This is where IP addresses come into play. Routers operate at this layer and determine the best path for data to travel from the source network to the destination network. Key protocols include IP, ICMP, OSPF, ARP. For example, when you access a website on the internet, routers use this layer to determine the best path for your data to reach the server. So this layer is essentially responsible for network routing and logical addressing. The transport layer ensures reliable data delivery between devices. It controls how data is transmitted and ensures that information arrives correctly. Two very important protocols operate here: TCP Transmission Control Protocol, UDP User Datagram Protocol. TCP ensures reliable delivery with error checking, packet sequencing, data retransmission. UDP is faster but does not guarantee delivery, making it suitable for video streaming, online gaming, voice calls. So the transport layer is responsible for data reliability and delivery control. The session layer manages communication sessions between devices. It is responsible for establishing connections, maintaining sessions, terminating sessions. For example, when you log into a remote server or start a video call, this layer maintains the session between the 2 devices. Protocols associated with this layer include RPC, SIP, NetBIOS sessions. Think of the session layer as the conversation manager that keeps communication organized. The presentation layer is responsible for data formatting and translation. It ensures that data from one system can be understood by another system. Functions include data encryption, data compression, data translation. A system might convert data into formats like JPEG images, HTML web pages, video formats, document formats. Encryption technologies like SSL and TLS also operate here. So this layer ensures that data is readable and secure. The application layer is the top layer of the OSI model. This is the layer that users interact with directly. It provides network services to applications such as web browsers, email clients, file transfer tools. Common protocols include HTTP, HTTPS, FTP, DNS, SMTP. For example, when you open a website in your browser, the request starts at the application layer. This layer allows software applications to communicate with the network. When data is sent from one device to another, data starts at the application layer. It moves down through all layers. Each layer adds its own information. The data is transmitted across the network. At the destination device, it moves back up through the layers. This process is called encapsulation and decapsulation. The OSI model is one of the most important concepts in networking. Understanding these 7 layers helps IT professionals troubleshoot networks, design better systems, understand how communication works on the internet. Let's quickly review the layers: physical, data link, network, transport, session, presentation, application. If you found this video helpful, don't forget to like, subscribe, and share it with someone learning networking. Thanks for watching, and I'll see you in the next video.